So hello everyone. Thank you for joining me today. My name is Jayavardhan Shukla, and I'm excited to share with you an overview of integrating external APIs with Liquid Galaxy. So in this talk, I would explore the fundamentals of API, how they work, their architectures, different types of APIs, and the technologies like WebSockets and SSH, which helps enhance the performance and security of our applications. So here we go. So let's start with the basics first. We know that an API or the application programming interface is a set of rules that allows one software application to communicate with another. Think of it as a contract between the applications that defines how the data should be requested and delivered. So, for example, when we use a weather app, then it sends a request to a server via an API, and it receives the current temperature data in return, often in a structured format like JSON or XML. So APIs generally define requests and responses and how it should be written. This diagram illustrates the same concept. We can see that the end users are connected with their applications. They are using them. They are the end users basically. So they basically generate a response for fetching some kind of data to the internet. The internet then diverts the response to the requisite server farm or the data source. The data source or web server contains the database. The database returns a response and it goes back to the application and it demonstrates it. This whole communication of this whole nuance of request and response is basically handled by APIs. So now we would understand different types of API architectures that are there. Some of them are mentioned here. So SOAP stands for Simple Object Access Protocol. It basically delivers the data in the form of XML format. So it is very nice for XML based enterprise applications that totally depend on them. So it can easily implement SOAP concepts. However, SOAP has their own vulnerability issues. They're not generally considered very safe. Rest basically are the resource intensive APIs. They generally written in JSON or XML or whatever sequential or the sequential or layer based data formats. So these are used for basically these are resource based for web servers. The next is GraphQL. GraphQL is a query language. The One of the benefits with GraphQL is generally that they reduce the network load. The next thing is gRPC. gRPC are a bit more uncommon ones because they are mostly used with microservices, but they are very high performance in nature and they are very intuitive as well. So the next thing is WebSockets. WebSockets allow bidirectional low latency data exchange. So the WebSockets basically have a hidden TCP layer with them. So they work upon them, but the way they communicate over is through a handshake. A handshake basically means an initial communication between the client and the server, or the application and the data source, as we can say. The webhooks are asynchronous in nature and they are generally used for event driven applications. Uh, so, how do APIs work? So APIs generally consist of client, server, and response. So apart from the text mentioned here, we can try to understand the APIs in a nutshell. In simple terms, here's what happens. So generally, the client or the requester it sends a request to the API, right? For instance, a weather app requesting some temperature data of a particular place. So the server, or which is generally the provider of the data source, it processes that request and fetches the data. The response is returned by the server with the requested data. The requested response cycle is fundamental to how the applications exchange data seamlessly. So this can also be seen by this diagram here. The web app communicates to the web server by the API. Web server is connected to the database. The data source is returned to the application again. So here's another example of the same. Consider that we build a mobile application consisting of a UI in which a user can upload their photo and write a message. So the user basically takes their photo, writes some message as hello or something else, and then they try to share them. So basically, as soon as they click on the share, this data is basically sent to the server application API. The API basically registers the data. They can basically save them or they can process them as and when required, and then the user can use the API functionality to basically again fetch the results. We can see that it's of a correct. The user application is directly connected with the API to share the message. APIs are also interfaces just like the mobile UI interface. However, they are generally the interfaces associated with data communication. So there are numerous examples of applications in Liquid Galaxy. A few of them are mentioned here. First of all, in maps and navigation APIs, we can do route planning. We can integrate Google Maps or OpenStreetMaps via their API, using their APIs. We can also do street views in the Google Maps by using the Street View APIs and other systems as well. The next things are IoT and smart city APIs. We can build smart city dashboards, disaster alerts, air quality monitoring systems, and so on and so forth. Social media APIs help us to get emergency updates about something that has appeared, which is basically related to a project. Twitter and RSS feeds also do the same thing. Something that comes and that needs to be displayed via some overlays or something in Liquid Galaxy. Below that, the overlays are generally shared over balloons, so these data can be displayed there as well. So the next thing is traffic and transport APIs. We can do transit tracking, we can do live traffic data. Then business analytics APIs for enterprise dashboards and financial trackings and so on and so forth. Finally, weather APIs for forecasts and real-time weather data. So the first thing that we are going to discuss are WebSockets. What are WebSockets? WebSockets are basically bidirectional communication protocols. They allow for a two-way communication over a single persistent communication. There are various examples of WebSockets like real-time data updates, efficient multi-screen sync, low latency, and reduced network overhead. So the WebSockets work by delivering a handshake. A handshake is basically the initial communication. So we know that the data updates that are needed to be done are to be done immediately. Multi-screen synchronization is very much relevant here because some data needs to be sent to certain screens, some data then needs to be sent to a different screen, and basically they have to be done simultaneously. In those cases, WebSockets can be very handy. So they are since their latency is reduced and the network overhead is minimized. So in the context of Liquid Galaxy, which is all about creating immersive synchronized multi-screen experiences, WebSockets are an excellent tool for ensuring real-time data updates across all displays. So under the hood, what is happening is that WebSockets do operate under a TCP connection. So once the connection is established, the data is exchanged as a series of frames. We are going to talk about the frames in the next slide. But first, we would look about what a handshake request is. Handshakes are basically, we can say, initial communication methods that initial communication messages that are sent from the client and the server side. Both of them send their own handshakes, and as soon as the handshakes are confirmed from both the client and the server sides, the communication is established and continuous data flow can be handled. So for reference purpose and understanding the WebSockets in depth, including the architecture, there is this document RFC 6455, which is a very essential basically foundational document. So we are gonna just see the document for once. So this is the document generated by the IETF, also called as the Internet Engineering Task Force. Basically scientists of Google developed this. So it is basically a reference standard, this document, and it basically tells us about the WebSocket protocol in depth. So we can see that it's a very extended basically document. It contains everything about the WebSockets. especially concerning to its architecture and how the WebSocket generally works. So anybody who is interested in knowing about the WebSockets can reference this document in depth. So yeah, so here we can see that this is the handshake payload that is sent by the client. So we can see that this is the handshake payload that is sent by the client, and on the right side is the handshake payload that is sent by the server. So the server receives the client side payload and the client receives the server side payload. As soon as they confirm they have received them, they establish a connection between the two. So this is a general basically structure of the payloads, the handshake payloads. Next are basically the WebSocket frames. So we can say that the frames are the basic units of the data exchange. So the data in the WebSocket is in the form of frames. The frames have a general structure which is shown in this diagram here. The diagram shows how the payload data is arranged in the form of frames. The frames have a certain length called as the payload length. The OP code is the 4-bit code 4-bit code which defines the type of the frame being sent. So it tells the receiver how to interpret the data. There are some common OP codes like 0 into 0, 0 into 1, 0 into 2, and 0 into A. So the two things that need to be focused on is the ping frame and the pong frame. So the ping frame is generally 0 into 9. It check if the connection is alive, so we can ping via the we basically use the ping frame to check if the connection is establishing or not. Pong frame is basically a response to a ping frame. So when we ping a server, it basically gives us a pong, and this ping pong connection basically helps us to see if the connection is alive or not. So if we have to close the connection, there is this 0 into 8 OP code. If we have to do a binary frame for a non-text data, then we can use 0 into 2 OP code. 0 into 1 OP code is used for text frames, and 0 into 0 OP code is called as the continuation frame, which is used for fragmented messages. So the next thing is payload length. We can see that the payload length is generally specified as 7 bits. It actually specifies the size of the actual data being sent. The structure varies based on the value. So for payload length of 0 to 125, it is directly represented in the 7-bit field. But for payload length of 126, which is also called as the extended payload length, you can see that the next 2 bytes or 16-bit unassigned integer is used for 126 payload length. It specifies the actual payload length. Then 64-bit unassigned integer or 8 bytes integer is specified the actual payload length of the 127 type. So this structure allows the WebSockets to efficiently handle both the small as well as the large messages. So after the WebSockets comes the RESTful and SOAP APIs. So we know about the RESTful APIs a lot, and we might also have utilized them in our applications while creating various applications in web or in mobile and so on and so forth. So these are the widely used web service communication protocols. Which each have their own strengths and use cases. So the strengths of the REST lie in its lightweight and fast usage. They use JSON or XML. They work over HTTP secure. They are ideal for mobile, web and mobile applications because of their secure data and lightweight, usage. So REST architectural style allows the applications to communicate over HTTP as well. There are various key characteristics. The usage of HTTP methods like get, post, put, and delete can be used by the REST framework. The stateless architecture is there. That means that each request is independent. The server does not store any client session data. And basically there are URL based resources. That means that the REST treats everything as a resource access via the URLs. So for that URL access we can use URI as the basically sending medium. So next thing is SOAP. SOAP stands for Simple Object Access Protocol. These are protocol based that basically strictly follow the XML structure. They support additional protocols like they work over HTTP, SMTP, TCP, etc. They are stateful and can be stateless as well. They have built-in security and reliability, like they include WS security or asset compliance and messages validation and so on and so forth. They are basically generally slower compared to the rest, and they are heavier as well, so that they would consume the more processing time. You can see that this is a particular joke about REST as well as SOAP APIs. You can consider Martin Lawrence as your data. So the data is sent by the SOAP standards. So the send as soon as the data and the SOAP standards are combined, the data is sent to the server and becomes huge as a big mama. It generally gets connected, and in the rest what happens is that the data is sent without any standards, so that the transfer can be seamless. Okay, so the next thing is about the RESTful architecture. So we can see that the client to server data transmission is done via the JSON format. It can also be XML as per the requirements. HTTP or HTTPS, anything can be used. There are various HTTP methods like guest, post, delete, and pull that can use in order to get the data. The URL is sent along with the HTTP to where the server location or the object location is there in the server, and it collects that object and returns back in the same way. So this is a typical RESTful architecture. Next thing is the SOAP architecture. The SOAP architecture differs from RESTful in that it has its own standards. So first of all, data and the SOAP standards have to be combined together, and then the server basically returns the data via the SOAP. So there are various security vulnerabilities in RESTful APIs. So anything, there are always a few drawbacks associated with RESTful, because since they have become old technology compared to the newer ones. So first of all, the biggest drawback of RESTful is the lack of encryption. So basically, there's no encryption done for like SHA or 256. So that's why the security issues can arise. There are no authorization flaws. The injection attacks can be done because of lack of encryption. Data exposure can be another issue, and the CORS malfunction. That is such as the issues with the cross origin resource sharing is there. So understanding these vulnerabilities is the first step in mitigating potential risks. Okay, so next is the use of SSH with APIs for eliminating security threats. We know that beyond just API calls, SSH is an instrumental in automating various administrative tasks as well. It enables remote server management, the execution of commands on remote machines, secure file transfers using SFTP, which is very useful for Liquid Galaxy systems, or SCP. Automated backups and data syncing is also there, and tunneling for secure communications. So all of these features can significantly streamline operations in the Liquid Galaxy environment. We can see why the SSH layer is useful to us, because it uses cryptography to authenticate and encrypt connections between devices. It allows for tunneling or port forwarding. So we can see that an SSH call differs from a typical API call. In the API call, everything happens via the URLs, but in SSH there is a user at the rate server, so that SSH call can get encrypted. The user and the server can be there can be multiple users for the same server as well. But they have to establish their own independent tunnels or for that purpose. So the next thing is SSH for automation. We know that SSH is a very foolproof and a security concern tool. It is used can be used for remote server management, running commands on remote machines, using SFTP and SCP for secure file transfers, automated backups and syncing and tunneling and port forwarding. So the first step is that the client initiates the connection by contacting the server. The client contacts the server. The server sends the client a server public key. The client negotiates parameters and open sources the channel, and then it uses the it basically logins to the server host operating system via the public key. So this is how the whole thing happens under the hood. Uh, So now we are going to discuss about how we can use APIs with Liquid Galaxy. General outline of these is listed in this flowchart. First of all, you would fetch the data from external APIs by RESTful or any other medium. Then we can pass and process the API data. We can fetch out, basically scrape how much data is important to us, so we can collect that and we can scrape out the other things. We can convert the API into SSH commands. So as to we can echo the commands to the Liquid Galaxy, and we can send the commands to LG to display the synchronize display and synchronize the data. So there are a few example implementations of this thing. For instance, the traffic layers in the Google Earth map. We can see the whole traffic layer thing is real time, as well as because it changes depending upon the condition of the traffic. So if we can integrate this by using the Google Maps JavaScript API, we can collect the data and then we can formulate this data into an KML file, which can we can basically send to the Liquid Galaxy one after another as things change. So the second example implementation is the earthquakes from inside of the earth. We can see that this is all. This can very well be implemented in LG. So this is basically by USGS Earthquakes API. So this is a very popular API for getting the earthquake data. You can basically get all the overlays by using KML, and we can show the related data in the form of clouds. So this KML based generation is real time, and it can easily be done by using SSH as well as RESTful APIs. So yeah, this is it. Thank